Hi, ready for another notes video? Yay! We are up to module 7 now, and we are going to move away from stoichiometry, even though you were just getting so good at it, and we're going to move on to atomic structure. Module 7 is on atomic structure, and these notes are from Apologia Exploring Creation with Chemistry, 2nd edition, pages 201 to 208. When we start talking about atomic structure, we have to talk about electrical charge because everything on Earth has electrical charges. And the electrical charges that substances are made of have to do with the atoms that are contained within the substances. So let's take some notes on electrical charge. This should be probably familiar to you. Electrical charge can be positive or negative. And like charges repel each other, okay? So if you have two positive charges, they're going to want to move away from one another. Likewise, if you have two negative charges, they're going to want to move away from each other. On the flip side, opposite charges attract each other. There are even songs about this, about how opposites attract each other. I'm thinking of one from my high school career by Paula Abdul. We come together because opposites attract. That is way too old for you guys, but it's a catchy tune. You should look it up. Paula Abdul. Yeah, opposites attract. So it'll help you remember. Like charges repel each other, want to push away. Opposite charges, if you have a positive and a negative, they are attracted to one another. Another good example would be my husband and I. He is a bit of a crazy person, and I am extremely normal. And we fit together perfectly. Okay, like I said, also every substance on Earth has electrical charges. And don't be fooled, I'm actually the crazy one. He's very normal. All right, every substance on Earth has electrical charges. What I'm going to write is, if the number of positive charges equals the number of negative charges, the substance is neutral, all right? If the number of positive charges is equal to the number of negative charges, the substance is neutral. And most substances that we come into contact with are neutral. We don't get a positive or negative charge from them because their positive and negative charges balance each other out and neutralize each other. However, if there is more of one charge than the other, the substance takes on that charge. If there's one more positive charge in a substance, then the substance overall is positive. If it has one more negative charge, then the overall substance is negative. Okay? So if there is more of one charge than the other, more of one charge than the other, the substance takes on that charge. The substance takes on that charge. Now on to atomic structure. Atomic structure, all atoms have 3 components. Actually, I'm going to start this over for this section. Okay, atomic structure. All atoms are made up of 3 components. We have first the protons, or proton. Secondly, neutrons. And third, electrons. The protons have a positive charge. Neutrons, like it sounds, they are neutral. They do not have a charge. And electrons have a negative charge. Uh-oh, someone's calling mommy. Hopefully she's okay. Electrons were discovered by a man called Crookes. Discovered, I forgot a couple letters in there, but that says discovered by Crookes. And I'm putting this in there because I want you guys, of course, to be reading the module on your own. You're going to see the history of how we came to understand atomic structure as we understand it today. And Crookes was one of those scientists that had a big impact on the scientific world because before him, they didn't know about electrons. Okay? So be reading through there and get to know that history. So these are the three components of an atom. Now, atomic number. Okay, on the beloved periodic table, every element has a whole number above its chemical symbol, and they're all in order. 1, 2, 3, 4, 5. Okay, that's their atomic number, and it equals, this is cool, it equals the number of protons in the atom. The atomic number equals the number of protons in the atom. Come quick, I'll be right back. That was an emergency, people. We have now added a My Little Pony gingerbread house to my daughter's Christmas list. All right, the atomic number is the number of protons in the atom. So this is how elements are actually labeled as the element. It depends on how many protons are in the atom. If it has 1 proton, its atomic number is 1, and it is a hydrogen atom. If it has 5 protons, its atomic number is 5, and it is a carbon atom. I better have gotten that right. I better check. Is carbon 5? Indeed, it is not. Carbon is 6. If it has 5 protons, it is a boron atom, like I was thinking. Okay, so atomic number. Also important, atoms have an equal number of protons and electrons. Okay, and that would make sense because an atom is electrically neutral, and so in order to remain neutral and not have a positive or a negative charge, you'd have to have the same number of positive charges as negative charges. Okay, atoms are electrically neutral. So we have atoms have an equal number of protons and electrons because they are electrically neutral. Okay, if they are not neutral, there's another name for them. It's an ion, and we will get to ions in the future. Okay, so take a look at the periodic table and tell me real quick, how many protons are there in, say, fluorine? Okay, find fluorine on the periodic table. Oh, too many papers in my book here. Fluorine has an atomic number of 9, which means it has 9 protons. Okay, so how many electrons does fluorine have? That's right, 9, because it's electrically neutral. How many protons does copper have? Find it on the periodic table. Copper has 29 protons. So how many electrons does it have? Did I say electrons before for fluorine? I hope I did. Fluorine has 9 protons, 9 electrons. Back to copper. 29 protons, 29 electrons. Okay, good. Let's just write in a couple of examples. Example, fluorine, fluorine is just an F. Fluorine has 9 protons, therefore 9 electrons. Okay? Copper has 29 protons, therefore 29 electrons. Sometimes electrons, and I will do it myself, sometimes electrons are abbreviated with an E and then a little negative sign. All right? Let's get my extra papers out here. All right, for my last little tidbit of notes here, I have to talk kind of fast because my videos have to be under 15 minutes to be able to go on YouTube, and I've already talked too much about Paula Abdul and My Little Ponies or whatever. So, next up, determining the number of neutrons in an atom. You already know how to determine the number of protons and electrons by looking at the atomic number. Okay, first you need a definition, isotopes. Isotopes are atoms with the same number of protons, which means they're the same element, but a different number of neutrons. Okay? So they're atoms of the same element, but they have different number of neutrons in their nucleus. Okay? We haven't even talked about the nucleus yet, but the nucleus is the center of the atom where the protons and the neutrons hang out. So that's what isotopes are. For example, carbon. There are 3 types of carbon atoms. First type has 6 protons, you can write that out if you want, 6 electrons, and 6 neutrons. That's the first type of carbon atom. There's another type, number 2. The second type has 6 protons, of course, has to have the same number of protons or it wouldn't be carbon, has 6 electrons, has 7 neutrons, okay? And the third type has 6 protons, 6 electrons, and 8 neutrons. So these are what we call isotopes of carbon. They're all carbon atoms, but they have different numbers of neutrons, making them isotopes of one another. Isotopes behave identically in their chemistry. The only difference is their mass, which of course would be minuscule because atoms themselves weigh next to nothing. So the neutron would weigh less than next to nothing, right? And lastly, the mass number. The mass number is not found on our beloved periodic table, but it is the total number of protons and neutrons in an atom. So you add up how many protons, you add up how many neutrons together. That's what we call the mass number for an atom. From our carbon example, the first type of carbon. The first type of carbon has 6 protons and 6 neutrons, so the mass number would be 12. We write it like this, carbon 12, or we write it with a little superscript up above, a 12, and then a C. That's how we write the mass number. The second type of carbon atom had 6 protons, 6 electrons, and 7 neutrons. So what would its mass number be? That is correct. 6 plus 7 is 13. So that's what we call carbon 13, which we can write those 2 different ways. And the third type has 6 protons and 8 neutrons, giving it a mass number of, drum roll, 14. Carbon 14, or a little superscript 14, and then the big C. Okay? Now, because I'm running out of time, I want you guys to add example 7.1 into your notes. It's practicing with mass numbers and finding how many protons, electrons, neutrons in different atoms or isotopes. I know you can do it.